Azure Administrator certification, you already know that role-based access control, or RBAC, is not just another topic.
Oh, not at all.
It's really the backbone of cloud security.
It is.
It's also where Microsoft, well, they love to set up those subtle scenario-based traps that really separate the people who just memorize from the ones who truly understand the security model.
That is the perfect way to put it. Today, our mission is very specifically targeted at getting you to that AZ-104 level of critical thinking.
Right.
We are here to drill into the precise judgment calls you have to make to secure an environment, using the principle of least privilege. It's not nearly enough to know the role names.
No.
You have to understand the interplay between the role, the scope, and critically, the plane of access.
Okay, let's unpack this and stop falling for those, the most common line assumptions that lead to security vulnerabilities and, of course, failed exam answers.
Let's do it.
Our source material for this is a concentrated study pack, and it's built entirely around these high-stakes exam scenarios. So we're focusing on 4 critical dimensions that you absolutely have to master.
Okay.
Choosing the correct built-in role, determining the smallest viable scope, so all the way from the tenant down to an individual resource, actively and surgically avoiding over-permissioning.
Yes.
And truly grasping that crucial divide between additive RBAC and plane separation, the management plane versus the data plane.
And let me just add the immediate gravity needed here. This isn't just theory for an exam.
Right, this is real-world stuff.
Misunderstanding the difference between, say, contributor and owner, or even worse, assigning roles at the wrong scope.
Yeah.
That is exactly how real-world security holes are created.
And that leads to what?
It leads to configuration drift, massive potential data breaches, or, just flat-out audit failures. We are aiming for the secure, least privilege, correct strategies that will both guarantee you pass that exam and make sure you protect your production environments right out of the gate.
Let's begin where all access starts. Scoping. Before we even debate which role to use, we absolutely have to lock down where that role lives.
Because inheritance in Azure is the ultimate power mechanism.
Exactly. For a quick mental picture, just remember the hierarchy, right? You have the tenant at the very top.
Right.
Grouping management groups, which group subscriptions, which contain resource groups, which finally contain your individual resources.
And the single immutable rule is that permissions assigned at a higher level automatically flow down to everything contained beneath them. It's a waterfall.
So the most powerful tool an admin has for least privilege is just putting the role as low as possible.
That's it. Ensuring the role assignment happens as low in that hierarchy as you can possibly get away with. We need to look at scenarios 1, 8, and 9 to see exactly how we apply this surgical approach.
Okay, starting with scenario 1. We have a developer. They need full control over all the components that make up a single application. That's an app service, a storage account, a key vault, and an Azure SQL Server. And crucially, they are all packaged neatly within one dedicated resource group.
Right. And the reflex, the common pitfall here, is to assign contributor at the subscription level.
Because it's easy. It's right there.
It feels safe. Right. The developer needs to create and manage resources. The subscription is easy to find. But if you fall into that trap, you've just made a critical security error.
That's over-scoping to an extreme degree, isn't it?
Yeah.
If I give them contributor across the entire subscription, they now have the power to manage, delete, or reconfigure
Everything.
every other resource group, every other application, every other resource that lives within that entire subscription boundary.
Exactly. Their scope of responsibility was one app, and you just gave them the keys to the entire city. The blast radius of that mistake is enormous.
So what's the correct surgical approach here?
The correct RBAC strategy here is highly surgical. Assign contributor at the resource group scope. This is the sweet spot for developers and application teams. Contributor, when it's scoped just to that resource group, gives them full power, create, delete, modify resources, but it confines that power precisely to the application's boundaries.
So no access to other RGs.
No access to other RGs, no lateral movement capability. It's a clean box.
When we talk about contributor, it's really critical for the exam to know precisely what it allows. Can you clarify what contributor does and maybe more importantly, what it does not do in this context?
That's a great question. Contributor is the role for resource management. It lets you provision resources, delete them, scale them, configure networking, adjust all the infrastructure settings.
Right.
But it has 2 crucial limitations that the AZ-104 exam just loves to test. First, as we'll discuss later, contributor cannot assign roles to others. It lacks privilege assignment rights.
Right, that's the owner's job.
Exactly. And second, and this is critical for this scenario, contributor does not grant access to the data plane.
Which brings up that detail in our source material about the SQL data. If the developer has contributor on the SQL Server infrastructure, don't they automatically have access to the data inside the SQL database tables?
And that is a vital nuance.
Yeah.
And it perfectly foreshadows our data plane discussion.
Yeah.
The answer is definitively no.
No.
Absolutely not. Contributor grants control only over the server settings, things like firewall rules, performance tiers, or configuration. If that developer needs to actually read or write data inside the SQL database tables,
They need something else.
they need specific SQL Server roles assigned inside the database itself, which are part of a totally separate data plane model.
So contributor gets you to the front door of the resource.
But it doesn't open the files within. Its power ends right there.
Okay, let's move even lower on the hierarchy with scenario 8. Hyper fine-grained read access.
My favorite.
This scenario involves a third-party vendor who requires read-only access, but only to very specific resources, maybe just one VM and one load balancer, and certainly not the entire resource group.
This is the ultimate test of applying the principle of least privilege. The common pitfall is assigning reader at the RG level. The rationalization is always read-only is safe.
It sounds safe.
It sounds safe, but for a third party, or for compliance reasons, even exposing unrelated logs, internal storage metadata, or configuration details for other VMs within that same resource group is an unnecessary security risk.
So we have to go below the resource group. The strategy is to assign reader at the individual resource scope. Does Azure RBAC really let us isolate access down to a single VM object or just one load balancer configuration?
Absolutely. The scope hierarchy exists precisely for this purpose. If the vendor only needs to inspect the health and settings of a single load balancer and nothing else,
You give them access to just that.
applying the reader role only to that specific load balancer object is the perfect security posture. It avoids exposing any other unrelated resources, ensuring maximum isolation and compliance. The lesson is, the scope can and often should go as low as needed, even if it means dozens of individual assignments.
Okay, let's pivot to the opposite end of the scoping problem. Hard isolation. Scenario 9 addresses enforcing strict separation between environments. You've got production and development, and plot engineers must absolutely not access dev resources, and vice versa.
This is a fundamental architectural requirement, and the exam wants to test your understanding of what constitutes a true isolation boundary in Azure. The common mistake here is trying to use separate resource groups, say RGProd and RGDev, inside one subscription for isolation.
But wait a minute, if I use an Azure policy with a deny action on RGDev, preventing anyone from the prod group from touching it, wouldn't that solve the isolation problem using RGs? Why do we have to jump all the way to separate subscriptions?
That is an excellent question, and it gets right to the heart of the security model. While a deny policy can certainly help block actions, the fundamental issue is inheritance of privilege. If you have an admin, whether they're malicious or just careless, who is assigned the owner or contributor role at the subscription level,
They bypass it.
they automatically inherit that power over all resource groups and all resources beneath it, regardless of your granular assignments or even most deny policies.
So resource groups simply don't prevent that high-level inheritance flow.
Precisely. The subscription is the critical, non-negotiable border control. The correct strategy for hard isolation is to use separate subscriptions, subscription A for Trod, subscription B for Dev, and then you assign your environment-specific administrators at that subscription scope.
So the subscription is the real wall.
The subscription is the true isolation boundary in Azure. While management groups are great for grouping subscriptions, they facilitate inheritance. They do not isolate. Hard isolation requires separate subscriptions. End of story.
Here's where it gets really interesting and where the most sophisticated AZ-104 scenarios reside. We need to talk about separation of concerns, managing the container versus managing what's in the container.
The management plane versus the data plane. This separation is absolutely non-negotiable for security and for compliance. Think of it this way. The management plane is the administration of the physical box.
Like creating a VM.
Creating a VM, setting the firewall rules on a storage account, or changing a key vault's network access. The data plane is managing the contents inside that box, the files in storage, the SQL table data, or the secrets stored in a key vault.
And Azure Security needs different roles for each.
It requires different built-in roles for each plane.
Let's use the analogy you suggested before. If a storage account is a giant secure safe, the storage account contributor role lets you, paint the safe, change the door locks?
Move it, or even destroy it. But the data plane role is the one that knows the combination to open the door and access the money inside.
That is the perfect analogy, and we can illustrate that immediately with scenario 3, storage account data access. We need a data analyst. They must read and write blob data inside just one container.
Just one.
But they absolutely must not be allowed to manage the storage account itself, so no touching networking, access keys, or the firewall.
The common pitfall would be assigning storage account contributor.
And why is that the wrong move, aside from the obvious overscoping problem?
Well, contributor is purely management plane access. If the analyst had that role, they could change the firewall settings and potentially expose the entire account to the public internet, a massive security risk.
Oh, wow.
But here's the irony. They still couldn't reliably read or write the data inside the containers using modern best practices, which rely on Entra-ID access, not shared keys. They can manage the safe, but they still can't open it.
So we need to bypass the management plane entirely and go straight to the data inside the container. What's the surgical fix?
The correct RBAC role is storage blob data contributor, and critically, you assign it at the container scope.
Not the storage account scope.
No, the container scope. This role provides pure data plane rights only. Read, write, delete blobs, but it is surgically restricted. It prevents them from executing any management plane operations, like changing critical security infrastructure. This combination of a specialized role and a narrow scope enforces true separation of duties.
We see this exact same pattern with highly sensitive resources like key vaults in scenario 6.
We do.
An app team needs to manage key vault secrets only. They should be excluded from accessing keys and certificates, and also must not modify the vault's infrastructure settings like networking or access policies.
This scenario tests whether you know that Microsoft provides specialist roles for specialist data. The common mistake is just using Key Vault Contributor.
Which is way too broad.
Far too broad. It grants control over the vault itself, allowing the user to modify networking or access policies, which are management operations.
So we need the Key Vault Secrets Administrator, not the Key Vault Infrastructure Administrator.
Exactly. You assign Key Vault Secrets Officer at the Key Vault scope. Microsoft provides these built-in roles for granular components precisely because secrets, keys, and certificates have different sensitivity levels and different life cycles. The Secrets Officer controls the contents related to secrets, excluding keys and certificates, and most importantly, excluding any management configuration of the vault.
That's least privilege defined.
It is.
Okay, let's tackle a critical administrative distinction, billing. Scenario 11. Finance needs to review cost data, but must not modify resources. My initial reflex is always to give them the standard reader role at the subscription.
And that would be wrong.
Why would that fail the requirement?
That is one of the most common exam traps because the name reader implies visibility into everything. Seems logical.
It does.
However, the standard reader role, while it's excellent for viewing resource configurations, status, and metadata, it cannot see cost, billing, or financial data.
Why not? Is that a technical limitation or a compliance-driven one?
It's primarily compliance-driven. Billing information involves sensitive financial commitments and projections. To prevent standard resource administrators from manipulating or misrepresenting costs, Azure segregates this data plane.
So there's a special role for it.
There is. To solve this, you must assign the purpose-built role, Cost Management Reader, at the subscription or the billing account scope. If your finance team complains they can't see the numbers, this is the role they are missing.
Finally, in this section, let's revisit log analytics. That's scenario 12. A developer has contributor on an app service but suddenly can't view logs in the associated log analytics workspace. Why doesn't contributor on the app service automatically grant access to the logs? It seems so intuitively linked.
It seems linked because the app service sends the data there, but the correct explanation is that the log analytics workspace is itself a separate managed resource and, crucially, has separate RBAC boundaries.
So there are two different sets of permissions.
Exactly. You have management RBAC for the app service, the sender, and you have data RBAC for the log analytics workspace, the receiver.
So my contributor rights on the application infrastructure don't travel over to the database where the logs reside.
Precisely. Contributor allows them to manage deployment slots or scale settings on the app service, but accessing the data inside the log analytics workspace requires data plane permissions specific to that workspace.
So the fix is another role assignment.
The correct fix is a separate assignment. Assign log analytics reader or log analytics contributor directly at the workspace scope. This scenario reinforces the rule. Always check the RBAC for the target resource you are trying to access, regardless of how logically linked it seems.
Okay, contributor is the default. It's
Yeah.
the Swiss Army knife, but we're learning that it's often just massive overkill.
It really is.
This section is all about resisting that contributor urge and finding the precise, low-privilege roles needed for specific day-to-day operations.
We need to view contributor as a tool for automation or infrastructure deployment, but rarely for human administrators performing routine tasks. Scenarios 2, 4, 7, and 14 show why finding a more restrictive role is always better for security, hygiene, and compliance.
Let's look at scenario 2. Strict VM operational access. We have a Tier 2 support technician. Their job description is simple. Start, stop, or restart VMs and view metrics for diagnosis.
That's it.
They absolutely must not modify network settings, resize the VM, or, most critically, delete resources.
And if you give that technician contributor, they can wipe out the production machine.
Wow.
They can change its networking stack and IP addresses or introduce configuration vulnerabilities. That is fundamentally incompatible with the principle of least privilege for routine operational tasks. The wrong trap is defaulting to contributor because it's easy.
So we need a surgical built-in role that covers just those basic operational needs without the ability to destroy or reconfigure.
And that role is the virtual machine operator role, assigned at the resource group or even the VM-specific scope.
What makes that one so perfect?
What makes it perfect is its restricted action set. It provides the minimal privileges required for day-to-day operations: start, stop, restart, and diagnostic views. It specifically denies the rights to reconfigure, delete, or manage sensitive components like networking interfaces or storage disks.
So it perfectly aligns the role scope with the technician's actual job function. Now, let's talk automation in scenario 7. We have a CI/CD pipeline, maybe Jenkins or Azure DevOps, and it needs to deploy, modify, and manage VMs, storage, and networking. It needs full control over resources, but it must not be able to manage RBAC.
If an automated pipeline could assign roles, you have created a catastrophic security vulnerability, a huge privilege escalation risk.
How so?
Any compromise of that pipeline's service principle instantly grants an attacker the ability to grant themselves owner access across the entire subscription. Therefore, assigning owner is the cardinal sin here.
The logical choice, then, is contributor assigned to the pipeline's managed identity or service principal.
That's the secure choice. Contributor provides full resource control deployment, modification, deletion, without the ability to assign permissions. For automated deployment processes, this is the appropriate and secure level of access.
And if the pipeline only touches one resource group?
Then we scope contributor down to that RG, maintaining the principle from Section 1, always be as narrow as possible.
This leads us directly to the technical difference between the top roles in scenario 4, preventing privilege escalation.
A critical one.
A senior DevOps engineer needs to modify all resources in the subscription but must not be able to assign permissions, so they can't elevate their own privileges or those of others.
This is a favorite AZ-104 question, and it's designed specifically to test the difference between owner and contributor. The wrong trap is assigning owner or user access administrator, UAA.
And why is that wrong?
Both of those rules, by their very design, grant the ability to manage access assignments, which is the one thing we're trying to prevent.
So if the requirement is total infrastructure control minus access control, the answer is clear.
Assign contributor at the subscription scope. Contributor grants near total resource management rights for everything under that subscription. They can delete everything, rebuild everything, but they fundamentally cannot touch the roles assigned to others.
So it prevents the DevOps engineer, or a compromised account, from elevating privileges.
Which is a vital security control. Contributor for resource management, owner or UAA only for access management. Keep them separate.
Finally, let's consolidate these operational roles in scenario 14, where we see how they scale in a 3-tier support hierarchy.
Right.
Tier 1 needs read-only access. Tier 2 needs the ability to restart services. And Tier 3 needs full operational control.
This consolidates all the lessons we've learned. Tier 1 is easily solved with the low-privilege reader role.
Simple enough?
Tier 3, needing full resource management and deployment capabilities, gets contributor.
Okay, and what about Tier 2, requiring that specific limited operational action, just restarting services?
Well, if we mistakenly give Tier 2 the reader role, they fail the job requirement because reader cannot execute actions. It's read-only.
So they can't do their job.
They can't.
Mm.
Therefore, Tier 2 must be assigned the virtual machine operator role. This creates a beautifully defined privilege escalation ladder. Read-only, then operational control like start-stop, then full resource control, with contribute.
That's secure, transparent, and meets every requirement.
Ex-
We've covered roles, scope, and the management data divide. Now let's look at the trickier bits: inheritance paths, identity boundaries, and dealing with unexpected access. These are really the hallmarks of advanced governance and troubleshooting.
This section deals with scale and complexity. We start with Scenario 5, multi-subscription consistency. A cloud architect manages resources across 5 different production subscriptions and needs consistent permissions applied across all of them without performing 50 different assignments.
The wrong trap is definitely assigning roles individually per subscription. That's a management nightmare just waiting for configuration drift.
It is. The correct strategy involves leveraging the level above the subscription, the management group, or MG.
Okay.
We assign contributor or reader at the specific management group that contains all 5 of those subscriptions. Because permissions inherit downward, a single role assignment at the MG level immediately applies consistently to all contained subscriptions, resource groups, and resources.
So MGs are the governance tool for consistency and centralized application of policy, whereas subscriptions are the boundary for hard isolation. They fulfill distinct, non-overlapping functions.
Exactly. If you need to ensure every subscription in your environment has a baseline set of administrators, the management group assignment is the most efficient way to do it. It drastically reduces management overhead. However, this centralized power comes with risk, which brings us perfectly to troubleshooting.
Scenario 10, diagnosing unexpected privileges. This is the real-world troubleshooting test. A user who is explicitly assigned only reader at the resource group level is somehow able to modify and delete resources.
They can do more than they should be able to. It's a classic "how is this possible" moment.
So what's being tested here?
What's being tested is a foundational understanding of additive RBAC and inheritance. The wrong assumption is thinking the reader role itself is somehow magically elevated, or that one assignment dictates their total access.
So we need to trace the path backward. The correct root cause must be that the user has a higher privileged role-like contributor or owner assigned either at a higher scope,
Like the subscription, or MG.
or via membership in an Entra ID group that itself has a higher privilege role assigned somewhere else.
That is the core reality of Azure security.
Yeah.
RBAC is additive. A user's total access is the sum of all their inherited and direct assignments.
So if any assignment, no matter how high up the hierarchy, grants them contributor, they are a contributor.
They're a contributor. The only way to definitively know their total access is the troubleshooting method. Use access control, IAM, then check access, then effective permissions. That tool reveals the total privileges and, crucially, where they inherited them from. This is essential for auditing and for passing the AZ-104.
Let's now look at the biggest identity boundary separation in Azure. That's Scenario 15, mixing Entra roles with RBAC. We have a user who is assigned Global Administrator and Entra ID, the ultimate identity power, but they still cannot access standard Azure resources like VMs or storage accounts.
This is perhaps the most common confusion for administrators who are transitioning from on-premises Active Directory.
I can see why.
The correct explanation is that Entra roles, like Global Administrator, are scoped to identity management only. They manage users, groups, application registrations, and licensing. By default, they grant 0 resource plane permissions.
So a global administrator can reset the password for every single user in the organization.
Yep.
But they can't even see the status of a VM in a resource group.
That is the hard truth of the separation of powers. The identity plane is entirely separate from the resource plane. To manage VMs or storage, that user needs an explicit Azure RBAC assignment, owner, contributor, or reader at the necessary resource scope.
So the exam trap is assuming GA means administrator of everything.
It absolutely does not. GA does not equal owner. Remember that.
Finally, let's wrap up with Scenario 13, preventing specific deletion. This is the scenario where users need to manage VMs, start, stop, modify configuration, but they must not have the ability to delete them.
This is a classic test of granularity versus built-in roles. The most common mistake is thinking the virtual machine contributor role prevents deletion. It does not. Contributor roles include the delete action. And VM operator is too restrictive because it doesn't allow configuration changes.
So if no built-in role fits the exact requirement, what is the AZ-104 preferred solution?
The primary correct strategy is to build a custom role explicitly excluding the specific action. Microsoft.compute virtual machines delete.
A custom role.
Custom roles give you surgical control down to the individual action level, which meets the requirement perfectly. Manage infrastructure, but cannot execute deletion.
I know you mentioned a secondary method for protection.
Yes, the alternative protection strategy is applying an Azure resource lock, specifically a cannot delete lock at the resource level.
But that's different.
It is. While effective, locks are a structural guardrail. They block all deletions, including legitimate ones by owner-level accounts. For an RBAC-specific question that requires managing permissions without blocking privileged users, the custom role is the superior, most flexible, and always the preferred exam answer.
We just completed a dense but really critical deep dive into 15 scenarios designed to stress test your RBAC judgment for the AZ-104. This knowledge isn't just about passing. It's about establishing a secure foundation for every environment you touch.
Let's just solidify the 5 non-negotiable takeaways from this.
Right.
First, always enforce surgical scoping. The scope should always be as small as possible. Resource is better than resource group, and resource group is better than subscription.
Least privilege starts with the location of the assignment.
That's it.
Second, always differentiate between the management plane controlling the resource configuration, the box, and the data plane controlling the contents, the files inside.
And you almost always need separate specialized roles for data access, like storage blob data contributor. They're not the same thing.
Third, respect the contributor spectrum. Contributor is the default for automation and full resource deployment.
But it is almost never appropriate for simple operational tasks. Use roles like virtual machine operator instead. And never use contributor when privilege escalation prevention is your main concern.
Fourth, the only true hard isolation boundary in Azure is the subscription. If you need guaranteed separation between high-risk or regulated environments, you need separate subscriptions.
Management groups provide consistency. They do not provide isolation. That's a key distinction.
And finally, fifth.
Never confuse your security models.
Yeah.
Azure RBAC for resources and Entra ID roles for identity are separate security domains. Global administrator in Entra ID has no power over a VM unless you assign them an explicit Azure RBAC role. That separation is a fundamental security control.
That is a rock-solid foundation. It really hammers home that achieving least privilege requires thought. It's never the most convenient option.
And if we leave you with one final provocative thought to carry into your administration and your study, if you find yourself in the position of troubleshooting unexpected privileges, a user is over-permissioned, your first step should always be to trace the inheritance path upward using the effective permissions check. If you find multiple high-privilege roles assigned through different means, consider the implications of that additive RBAC structure. Does this mean your identity management is too complex? And what long-term governance risks are you introducing by assigning access broadly at the management group level, giving yourself consistency, versus maintaining granular contained control solely at the resource group level? The higher you set the permission scope, the wider the security blast radius becomes, and the more complex the troubleshooting will be when things inevitably go wrong. Think strategically about every single assignment.
Essential advice to protect your environment and master the AZ-104. Thank you for joining us for this deep dive into Azure RBAC.
Until next time.